Hi guys, welcome to this set of videos, and what we're doing is we're talking about points of concurrency in a triangle, and we're going to continue that discussion on points of concurrency in a triangle with now two more points of concurrency. Before we talk about those new points of concurrency though, we want to take a look at the essential question, what it is that we'd like you to be able to answer by the time we get to the end of this set of videos in this section of notes, and then how we're going to go about answering that question. So let's start off first with our essential question, and simply this. If I were to ask you to find the balance point, simply meaning the center of mass or the center of gravity of a triangle, how would you go about finding it? If you were to take a triangle, right, and I wanted to balance that triangle on the point of a pencil, where is the point that you would need to set that triangle down on your pencil, right? Set your triangle down on that pencil so that the triangle balances, perfectly balances on that pencil, on the tip of that pencil, right? That's what we're going to do here in this set of notes. It's actually really sort of an important idea when it comes to finding the center of mass of really any object. In this case, we're going to talk about triangles. Being able to find the center of mass, especially in things like cars or vehicles, knowing where their center of mass or their center of gravity is really important when it comes to finding the safety rating of that vehicle, and knowing whether that will be a vehicle that will keep its occupants safe in a collision or something like that, knowing, or even just how that vehicle will handle if weather conditions are not ideal, having a lower center of mass or center of gravity, really important. So being able to find a center of mass or a center of gravity, a balance point, is actually a really, really important idea that extends far beyond geometry and just triangles. Now, how do we do that? Well, students will identify the balance point of a triangle by constructing, I give you the answer right here, medians. We need to be able to find the median of a triangle. Turns out that medians will be a point of concurrency. We'll talk about that in a second. Students will find the centroid and the orthocenter. Again, probably two terms that you are not familiar with. We'll get familiar with them here in this set of notes. You'll be able to find those on a coordinate plane. And then students will use these properties. Of course, as always, we've done it in every section so far here throughout geometry to find unknown measures or links, right? A little bit of algebra. So here we go. Let's jump right into this. Again, point of concurrency, we're seeing this common theme, right? We're finding the points of concurrency of a triangle. We've already talked about the circumcenter. We've already talked about the incenter. And here in this set of videos, in these notes, we're going to cover the last two, the centroid and the orthocenter. We'll talk about the centroid first, and then we'll talk about the orthocenter after that. Now, where do these two things come from? First, the centroid is going to be the intersection of medians. We'll talk about what a median is, how you find it, and then we'll do some essentially algebra, solving problems using those medians. After we talk about the centroid, the point of intersection of medians, we'll talk about the orthocenter, which is going to be the point of intersection of the altitudes of a triangle. Another way of saying the altitude of a triangle is simply finding the height. What is the height of the triangle? There are three ways to measure the height of a triangle, and where those heights or altitudes intersect is going to be the orthocenter. Once again, it is worth repeating one more time. There's a ton of information here, and it is very easy to begin to confuse these points of intersection, these points of concurrency. I've said it before, I'll say it again. Flashcards are a great way to help you memorize information and keep it straight, right? I absolutely, if you're taking this class with me, I'm going to test you on these terms and definitions and what each of these points of concurrency tells you, properties about them. So it'll be really important that you keep this information straight, and we'll help you do that as we sort of go through these notes, talking about similarities and differences between these 4 points of concurrency. So, up first, medians. Now, medians are actually really pretty easy to find. What you're going to be doing with a median is simply a segment whose endpoint is a vertex, right? So you're going to start at a vertex, and you're going to draw a line, hence the word median, of a triangle, right, that goes to the midpoint of the opposite side. Midpoint of the opposite side. And of course, every triangle, because it has 3 vertices, will have 3 medians. So start at a vertex and draw to the midpoint of the opposite side. Now, why is midpoint really important? Well, that's really important because it'll then split that opposite side into 2 congruent segments, which you can see there in the diagram, thanks to these little hash marks right here, which tells you, right, that this segment and this segment are congruent. And there would be 3 of those. I draw a median from C to the midpoint of the opposite side, and I would draw a median from A to the midpoint of the opposite side, and where all of those medians intersect will be our centroid. All right, their point of intersection, their point of concurrency is what we call the centroid of a triangle. Now, like we said up in the objectives and even our essential question, why is the centroid important? Well, the centroid is the balance point. Of a triangle. Once you know where the centroid of the triangle, the point of intersection of the medians, you know the center of mass of that triangle. Simply meaning you cut that triangle out, you put the centroid right on the tip of your pencil, and that triangle will balance on the tip of your pencil because you have found its center of mass, its center of gravity. You have found the centroid of the triangle. Okay, so every triangle has 3 distinct medians. We already talked about that. And the midpoint to the midpoint of the opposite side. So let's go ahead and talk a little bit more here about medians. One more thing I need you to know about this centroid theorem before we start taking a look at a couple of problems, and it's simply this. Centroid theorem. So 3 medians will get you, right, the intersection of 3 medians is the centroid of a triangle. Now, here's sort of where the algebra part comes in. The centroid is always on the inside of a triangle. The centroid will always be on the inside of a triangle, which makes sense, right? If you're going from a vertex to the midpoint of the side opposite, there's no way that those 3 medians could intersect outside of a triangle. It's just not possible. You're drawing from a vertex to the median of the opposite side, or to the midpoint of the opposite side. It can't be on the outside of a triangle. It's just not possible. So they'll always be on the inside of a triangle, and here's really sort of where the algebra is going to come in, these formulas. It divides each median by the exact same ratio. All right, so what are those ratios? Here's what we've got. If you take, just for example, they give you all 3 down here. We'll just talk about 1 because they're all exactly the same. The distance A to X. Let me draw that in red. So this guy right here, this median A to X. That segment A to X. Again, really important. It's a median because it divides the opposite side into 2 congruent segments, right? Because it goes to the midpoint. So CX and XB are going to be congruent. But not what we're going to discuss here. Yes, important, and we'll use that information. But we want to talk about this ratio. So here's the way that it works. The distance from A to X, right? Whatever that distance is. In order to find the centroid, which in this case would be this point right here in blue, that distance from A to the centroid will be exactly 2/3 the distance A to X. Here's what that means. Let me give you a real quick example. So I'll highlight this guy for you right here. All right. Notice that they're all exactly the same. They're all 2/3, 2/3, 2/3, 2/3. So let me help you understand how this one works. You'll know how all of them work. Real simple example, let me show you. If I give you this line right here, there's X, there's A. Let's say I've just taken this line segment AX, I pull it out of the triangle, and I put it right there. I want that line segment AX, let's just say, for example, to keep things easy, that line segment A to X has a length that is 6 units. So from A to X, it's 6 units. Now, the way that this centroid theorem works is simply this. What this theorem tells you is that the distance from A to the centroid, which we'll call P, is 2/3, right? 2/3 the distance from A to X. Here you go. Here we go. If the entire distance is 6 units, all you need to do is take that 6 units, right, and divide it into thirds, which is really easy to do. You'll simply take the 6, divide it by 3, and a third is going to be what? Well, a third is going to be 2 units. Now, the distance from A to the centroid will be 2/3 of the entire distance. So from A to X is 6 units. To find the distance from A to P, where P is the centroid, I'll write that for you, P is the centroid, you're going to go 2/3 of the distance. Well, if a third is 2, how far do I have to go to get from A to P? I have to go 2/3, which in this case would be 4 units. So here is 1/3, 1, 2, that's 1/3. I need to go 2/3, so I have to go 2 more. There's 2/3. So how far is it from A to P? Well, it's 4 units. If the entire length is 6, from A to the centroid would be 2/3 of that, or in this case, 4. Right? So the way that this theorem works is simply this. All of the medians are divided by the exact same ratio, and that ratio is 2/3. If you know the entire length, find 2/3 of that length, and you'll know where the centroid is. Let me show you in a couple of example problems, which I've got for you guys on the next page of the notes. So if you head on over to the next page, I'll meet you guys there. We'll take a look at a couple of problems and how this theorem works.